The question is not SIL or HIL, because it's both at the same time. This has long been a wish of many development teams, and this is now a reality with SIL-HIL Co-Simulation. In many projects today, SIL and HIL are clearly separated. SIL for early software tests, HIL for final validation with real hardware. The problem? Integration errors often emerge very late, when software and hardware really come together for the first time. This costs time, generates retests, and introduces unnecessary risks into the project plan. With SIL-HIL Co-Simulation, we are changing precisely this approach. Instead of separate test worlds, we enable a common simulation environment. Part of your system run virtually in SIL, other parts already on hardware, and both are tested synchronously together. This means that integration scenarios can be tested much earlier and more realistically than ever before. What's in it for you? First, integration problems become visible earlier, not just at the end of development. Second, you can directly reuse existing SIL tests and models, without breaks, without duplicate maintenance. Third, you can continuously test with what is available, from early testing of the algorithms to the final validation of the entire ECU network. And in the end, you get shorter development times, higher test coverage, and more confidence in the results. So how does this actually work? At the core, the Hybrid Simulation Integration Layer, or HSIL, connects the virtual SIL world with the real HIL world. On one side, your virtual ECUs and models run in SIL, while on the other side, real ECUs and I/O operate in HIL. Both worlds are coupled to the HSIL integration layer. HSIL uses DDS as protocol. This coupling is flexible. You can couple 2 or more simulators, and it is not limited to dSPACE simulators. Signal-based as well as CAN and Ethernet communication are supported for data exchange. The result is a flexible simulation environment where virtual and real components interact seamlessly. And now we would like to show a demo, and I'll hand over to my colleague Steffen.
Thanks, Barbara, for the introduction. Let's take a look at a concrete example on how a setup can look like. In this demo, we are using our HIL simulator SCALEXIO to simulate the vehicle and the surrounding environment. At the same time, we are running an ACC algorithm on VEOS on this laptop here. The two simulations are coupled via our HSIL technology, utilizing signal-based communication over Ethernet. Now, let's go into the tools. As you can see here, both simulations are running in a simultaneous way and exchanging data in real time. This allows us to combine high-fidelity environment simulation with the virtual ECU functions in a seamless way. Now let's have a look at the scenario. Our ego vehicle is driving along the road. Ahead of it, there is another vehicle suddenly comes to a stop. As you can see here, the ego vehicle detects the situation correctly and performs a controlled stop right behind the leading vehicle. This behavior is enabled by the ACC algorithm running in VEOS. Now let's see what happens if we remove the virtual ECU component. I will stop the VEOS simulation, which means the ACC algorithm is now no longer active. As you can see now, the ego vehicle is no longer reacting appropriately. It does not stop and instead drives straight through the object. You can also observe that once VEOS is shut down, no further data is exchanged in the simulation. This clearly demonstrates how HSIL enables realistic interaction between virtual and physical components, allowing us to validate functions earlier in the development process and significantly reduce testing effort and costs. With that, I will hand back to Barbara, who will wrap up things with a brief summary.
SIL-HIL Co-Simulation is not a replacement for existing methods. It's the logical next step to combine virtual and real tests in a meaningful way. The question is not SIL or HIL, because it's both at the same time. You want to know more? Benchmarks, how to set up a SIL-HIL Co-Simulation, experiences from customer projects? then contact us at dspace.com.
dSPACE, your partner in simulation and validation.